So of course I want to start by saying thank you everyone for joining. My name is Cody Armstrong, and today we're discussing top-down design techniques in Onshape. So we're going to discuss the various ways that we have for doing top-down design and just some tips and tricks with this kind of modeling technique. Now I'm going to get into a simple intro into what is top-down design for those that may not be familiar with the term, but then we're going to dig into the details of doing this. How do we accomplish it in Onshape, multi-part, in context, and where would you use those techniques. So top-down design techniques and Onshape, as I always say with these webinars, I really encourage you to ask any questions that you'd like. There's a questions dialog in the GoToWebinar control panel. Feel free to ask any question, and I'll do my best to stop and answer the questions from time to time. So real quickly, a brief agenda before we get started. I want to introduce you to top-down design. I think there are users out there who may not be familiar with the term. It's very much an industry term, so it's not something that we created on Shape. It's something that you'll see in many different CAD systems. So I'll give you a simple introduction into top-down design and then discuss where it's used. And I think that's where I want to spend the bulk of the time is why would you do this and what are the advantages of doing this. Of course, the main thing I want to do here today, though, is show you how it's done in Onshape. And I want to give you a few options, things to consider when you're starting your top-down design in Onshape. And a big part of that discussion is discussing multi-part versus in context. And that's something that I want to take a moment to discuss. In fact, I'll probably be bringing it up throughout the entire webinar is when would you choose multi-part modeling versus in context modeling? And of course, answer any questions that you have. So as we're going through things, again, feel free to ask any questions through that questions dialog in the GoToWebinar control panel, and I'll do my best to stop and address the questions from time to time. All right, so let's get into it now. The simple introduction into top-down design. What is top-down design? And in short, you're just modeling parts within the context of other parts. You're modeling parts with relationships to other parts, building parts together. Now, I think it's important to note, there's top-down, and there's often what's referred to as bottom-up. And bottom-up design means you're modeling each part independently in isolation. And so as you're designing parts, you're designing one part by itself, you switch tabs to another part, you're designing that by itself, and then at some point you bring them together in the assembly. So that is what's often referred to as bottom-up design, modeling each part independently. Top-down design is the inverse of that. You're building all parts, or at least a large majority of parts, with relationships to one another. And that top-down design allows you to build a lot of contextual relationships that make your designs really powerful when we start talking about how they behave to updates and changes. So top-down design, there's other terms for it. I've heard the term in context, which is, of course, what we have in our assembly level. But in other CAD systems, in context is often just a term used for top-down design. So if you're familiar with in context design, very similar to top-down, what we're talking about here today. And the main reason to do this, rather than modeling each part independently, is it makes it very easy to build relationships between parts. It makes modeling those parts that tie things together very easy. If you find yourself modeling each part independently, you'll find yourself also taking a lot of measurements and jumping back and forth a lot between parts that are interrelated. So top-down design just lends itself to that kind of design. If you find yourself in a scenario where all of a sudden I'm taking a bunch of measurements to figure out what these values are and going back and forth between tabs, chances are you could have done it a little bit more efficiently using either multi-part modeling or in-context assembly modeling. So that's a simple intro into top-down design. Think of any scenario where you're modeling parts relative to other parts, right? All right, so how do we do top-down design in Onshape? And there's two answers, and that is multi-part modeling and in-context assemblies. Now, I'm going to go over in just a bit why you would choose one over the other, and there's some simple rules that can help, but realize there is some overlap here. Multi-part modeling is great if you're building all the parts together in a single space and you're starting from scratch, and you don't have to position a lot of things. But when we start talking about motion and we start talking about having to position a lot of parts, Then we start getting into in-context assemblies. I'm going to elaborate on this in just a bit. But the key thing to take away from this, I think one big thing to take away from this webinar, you really have two choices for top-down design in Onshape. You can model multiple parts together in the same part studio, or you can build parts in the context of the assembly. So let's get into multi-part modeling. So we'll start with multi-part modeling, then get into in-context, and then I'll explain some of the key differences between them. So the first thing, of course, multi-part modeling means you're modeling multiple parts in the same part studio. That's the key thing, and I'll show you an example of what this means in just a second. But there are a lot of benefits to this, the main one being it's very easy to create relationships between parts. Right? It's very easy for me to construct, the equal constraint between two pins or something to that effect, where if I change one, they both update. So it allows me to build this design that's very flexible to change, and will update many parts at once. And that's the key logic behind modeling this way. And there are a lot of advantages to discuss, and I'll get into greater detail in just a second. So let's dig into it. Now, as I mentioned before, we're going to start basic. I'm going to show you kind of the essentials that you need to create your first multi-part part studio. Then I'm going to get into kind of what's possible, and then one important workflow for using this technique. So let's start basic. I have nothing but a simple sketch, and I've already, just to give you a brief example of what this is the finished clamp arm. And if you look at it, it's really just a few of these arms with some pins tying things together, and then two clamp in pieces, right? So very simple design, and this is a great example where multi-part modeling has a big benefit, because I can model everything together in one part studio, and if I decide to make a bigger clamp arm or longer arms or something to that effect, I can change it in one place. So here I have a simple sketch called main sketch. Just one sketch with both arms sketched into place, and if I click extrude, let's start with, let's say, a simple 5mm extrude, and then choose the profiles that I want to extrude. Remember, you can select from each profile, right? So I can choose from the pieces of the sketch that I want to extrude, right? Now we'll set this to 2. I'll hit the green check, and now I have my first part in my part studio. So that's one of the first tips. You can drive multiple parts from the same sketch. For example, 2 arms of your clamp in this example are driven from that one sketch. Let's do this again. I'll go back to the extrude command. We'll just use the same sketch. We'll say 2mm, and I'll click on the regions that I want to extrude. Now keep in mind, by default, when you're doing this, it will want to join the two together. So by default, when I create this second extrude, it recognizes that this feature can merge with this previous extrude, and it defaults to that. You can see add, and it automatically selects my merge scope. So it's intelligent enough to know, hey, there's surrounding bodies that I can merge with, and I will if that's an option. But in this example, I actually don't want that. Right? I don't want this extrude merged with the first one. I want to create a second part here. So the key to this is new. In the extrude command, you have this option for new. Rather than adding this feature to an existing part, we're going to create a new part. Right? Now I can flip the direction, and most importantly, now I have 2 parts in my part studio, and 2 parts driven by the same sketch, by the way, right? So 2 independent parts, and I can go on from here. So I can make this even more, elaborate. Maybe I wanted to model the pins into place. Let's start a sketch. We'll sketch a circle here, a circle over here. We'll add a diameter to this one. Let's say 10mm. And now I accept. Now I've got 2 circles sketched. We'll create a second sketch, this time on the bottom face of the second arm, not on the top. And we'll sketch 2 more circles. Right. Now, a tip that I have is, in this example, I want it obviously concentric, right? But I also want this pin, this is a circle sketch for a pin that I'm going to extrude in a moment. I want it the same diameter as this pin. And it's easy for me to select this circle, set them to equal, and now my pins will have the same diameter. So just an example of the benefit, so to speak, of modeling multiple parts like this is it's easy for me using something as simple as an equal constraint to make these two pins the same diameter. Now keep in mind that's a big part of that is because they're on parallel sketch planes. When you start running into, sketch planes that aren't parallel, you may need things like variables to give you something like this. But keep in mind, again, we're driving two different pins in this example with one dimension, right? So now I've got 3 circles. We'll do one more. Now I've got 4 circles in these 2 sketches that I've created. So in the last example, I showed you how one sketch can drive 2 features. In this example, we can use one feature and reference 2 sketches. All right, so now I'm clicking on 2 separate sketches for my extrude command, and I'm extruding 4 different pins in a single feature. Right, so it's easy for me. Let's say up to face. We'll choose the mid plane. Green check, and now I've got 4 pins modeled in that one feature. So I just created 4 more parts with extrude 3 here. So now I've got 6 parts total in this part studio. Question, shouldn't add be named merge for the UI to be consistent? No, I don't feel that would be the case at all. Add is used throughout Onshape. I assume that the second pin will be made equal to the first selected. That's correct, yeah. Now, in my example, the first pin was constrained, right? So that drives, if it's fully defined, then that would drive the other. But first to second, if they're both underdefined, yes. Right. All right, so now I've got 6 parts in this one part studio. One other big benefit of this kind of modeling technique is it makes something like a Boolean very simple. So I may need to cut the pins to match these arms, right? And so I can do something like a Boolean subtract, select the tools as the 2 arms, and the targets as the 4 pins. What this will do is it will cut each pin to match the arm. Right. Another good example of a Boolean will, of course, be a mold. Right. If you want to subtract a part to create a mold, you use a Boolean technique. And mold modeling multiple parts with relationships to one another in that mold is another good example of multi-part modeling. One other tip with this command, in this case, I want to keep the tools that I'm referencing, which is the 2 arms. So I'm going to check keep tools. But most importantly now, if we hide these first 2 parts, you can see the pins have now been cut to match the arms. Right? So simple Boolean operations, another big benefit of modeling in multiple parts like this. So just keep in mind again, modeling multiple parts is very simple. The key things you want to keep in mind when you want to create a new part, make sure to choose the new option. And it doesn't matter whether it's extrude, revolve, sweep, loft. They all have new, add, remove, and intersect. Right? And these are define how this feature will interact with other features or parts in this part studio. So again, new is a big one. As you're creating your features, if it's a new part, a separate part, you need to make sure to select new. All right. Now, a big reason to do this is if you decide to make a change. So let's make a small change to this, say 45 for the length and 45 for the length here. What you'll notice is all parts immediately update. So both arms, of course, update, but the pins that were referencing that original sketch also shifted in position, right? So again, the key thing here is I'm driving this entire design with a single sketch, including these pin locations. And if I decide to change different arm lengths or different angle positions, I would instantly see all of them update, right? And so it allows you a lot of insight into the design. Now, this is a very simple example of multi-part modeling, just a few pieces. The key thing to keep in mind is I've really built everything from scratch here. So I'm sketching everything from a blank part, so to speak. But there's also an important workflow of working around other parts that you may get from other systems, or maybe you're in a library of data that you have. And that's a different workflow. I'm going to walk you through that in a second. But if you're building everything from scratch, real simple example like this, multi-part modeling is really a big advantage, right? You can build everything together. Now, this can be taken, multiple levels further. So I can jump into, this is a pneumatic cylinder part studio. This is one part studio with 28 parts. The neat thing about this is the part studio is driven by two variables, which would update all 28 parts if they were both changed. So I have a bore and stroke variable in this part studio. And if you change one, all of the parts will update. And so, many users out there will ask, well, is it easy to build different variations of a design? I can easily change the bore or stroke, have all the parts update because they were built with relationships to one another, and, build different variations of pneumatic cylinder sizes just by changing two values, right? So this is, taking that multi-part modeling example I was showing you a moment ago and taking it one step further. You can see that this was started with a simple sketch and extrude for the barrel, and then everything was kind of built around that. There are a lot of different techniques you could follow with this, but the main thing I want to show you is just what's possible. You can build everything inside of this part studio if you choose to. Now, as you start to get more and more and more parts, and you start to get into the thousands, you'll want to break things up in a reasonable manner. And oftentimes, this might be a sub-assembly of ultimately what will go into my top level, and I would separate out my part studio. So I wouldn't say model everything in a single part studio, but model the interrelated parts, the things that make sense to model together, put them in the same space, in the same part studio. Question, is it possible to scale an entire part studio? Well, let's try it. I think you could just Windows select and scale. Yeah, I would try it. If you do a transform, you'll see scale uniformly, and then just Windows select every part in your part studio and set your scale in a point. I don't see any reason why that wouldn't work. I would have to test myself to be sure, but yeah, I think that should work just fine. Is it possible to do a Boolean subtract with clearance? Very good question. Yes, there's an offset option. So just keep in mind, in the Boolean command, while you're doing that Boolean subtract to subtract the arms from the pins, you can say, no, I want a 1 millimeter offset between faces. And what that will do is, of course, give you that offset between the geometry. So yes, in short, the answer is check offset, and then you can individually select faces to offset, or just say offset everything by X, whatever you type in there. All right, so this is the pneumatic cylinder, a good example of a multi-part part studio. And the other thing I wanted to stress with this is, this design has motion, but it's very, very simple motion, right? In and out, and the design really isn't focused around motion. It's just that one in and out motion. So it's a good example of where multi-part modeling makes a lot of sense. Now, the other workflow that I wanted to show is working around imported geometry, or maybe just parts that you've modeled elsewhere. So the example that I have is, let's say that I've been sent two parasolid parts, two random parasolid parts that I need to bring together and model a part around, right? This is a different workflow than the two past examples, because in those examples, I started from scratch. I started from a sketch, and everything's driven off of that and built entirely in that one part studio. But in this example, I need to bring in parts from other sources, whether that be parasolids I've been emailed, maybe it's even parts I've modeled long ago by themselves. I need to bring them in and model around them. There's a few things to consider with this workflow that I wanted to mention. So let me jump back real quickly here to important multi-part modeling techniques. And the big thing that I want to stress is this going to use the derived feature. So the derived feature is how you're going to import that part into the part studio, but that's only half of it. If it was modeled in the correct orientation and happens to be modeled in the correct orientation, then you don't have to do anything more. Just simply derive it in. But the likelihood of that is pretty slim. So it will also involve a second step, and that is transform with mate connectors. So there's two steps. You import the part into the Part Studio, then transform the part into place with mate connectors. And I say mate connectors just because I think that's the easiest approach. You can transform a number of different ways, but I think most users are doing this. More complex Part Studios are using transform with mate connectors. So two very important techniques when we talk about working with geometry from the outside, right? Not like the previous examples where everything was built from scratch in that one Part Studio. I need to bring stuff in from other sources. So what would I do here? Let's go back to the example. So here I have the bottom casing, you can see, is a parasolid here, and a top casing parasolid. So two different parts. And if you look at their orientation relative to the origin, it's really, they're way off, right? So they're really kind of modeled in this arbitrary position with respect to the origin. And when we go to derive them in, they're going to reflect that same position. So let me walk you through this. I need to bring this bottom casing, this top casing together, and then model, let's say, a flange around them. I'm going to create a new Part Studio, right, a new blank part. And the first thing I'm going to do is derive these parts in. So you'll see the derived feature on the far right here. And I can just choose, okay, I want the bottom casing. And then I'm going to, of course, bring in the top casing. Right? So the key thing that I want to stress here is their positions are, of course, not correct. Right? So as I bring these in, they're positioned randomly, and they're really positioned in the orientation they were modeled. That's an important thing. So if you don't control that, then you'll have to move these around. Now, the question then is, how do we move them around? You know, how do I position this on the origin, and how do I get this sitting on top of that? And the answer is transform with mate connectors. Now, transform with mate connectors means you need a mate connector. So step one in this process is creating the mate connectors. What I'm going to do is I'm going to go back to the bottom casing. I'm going to create a mate connector in this Part Studio. The main reason for that is if I happen to insert this anywhere else, the mate connector will go with it. Right? So I'm going to insert the mate connector in this Part Studio, right here at the center of this part. Right, so just click Mate Connector, select the reference, very much like, you know, mating a part in an assembly, and it's going to create a mate connector at that reference for you. So we'll do that one more time. Let's go to the top casing, Mate Connector. I'll select again that center point. Right, green check. So these are essentially the 2 points that I want to bring together on each part. So I define each mate connector. I go back to the Part Studio, and now I can begin using that transform. Now, for me, though, this first step is I want to move this part over to the origin. I hate that this is shifted off of the origin. So I'm going to insert a mate connector at the origin. Right? We can define its owner part as our imported part, but then I can use the transform and say transform from here to here. Right? So we can do transform by mate connectors, right? Say from here to here. And the entities I want to transform are the part, and a big tip that I have, not just the part, but also the mate connector, right? Otherwise, the mate connector will stay out here in space. So when you do your transform, include the mate connector if you're, you know, in a similar scenario. So I hit the green check. Now I've transformed that part from its random position in space to my origin. Right? The only step I have left is to do one more transform to position the top on the bottom here. So again, transform by mate connector. The part that I want to transform is this, again, plus the mate connector. And then I want to transform from this mate connector to this one. Right? Try that again, from this one to that one. Right? Now, very much like a mate in an assembly, you have some options, and you're going to need them from time to time for scenarios like this where the part's orientation is upside down. So very similar to a mate, you can flip the primary axis and you can reorient the secondary axis. So you have that control. Again, very similar to actual mates in an assembly. So I hit the green check, and now I've positioned both parts with respect to my Part Studio. Now I can start my sketch using faces, using all the same multi-part modeling techniques I was using earlier, and I can even constrain it to the edges of the part. I can even convert edges if I needed to, but it's very easy now for me to build my flange, so to speak, with relationships to those parts. Right, so let's use convert, and we'll just do a simple extrude. Let's say maybe 0.25 and green check. So now I've built my flange piece with respect to the two case pieces that I was emailed, right? These two parasolids. And the key thing there is it's not just a matter of deriving them into the Part Studio, but then positioning them in the Part Studio. Now, keep in mind a question that gets asked, I think I see it there. Is it possible to turn off the mate connector icon on a derived feature? You can hide the derived feature. So just a tip, if you don't want to see the mate connectors after doing this, hide the derived features in your feature list, and then the mate connectors will disappear. Right. Next question. What if your derived part has multiple mate coins? I assume you mean connectors. Do they all need to be selected to transform? No, remember, you're only transforming from one to one in this example. So I'm saying from this mate connector to this mate connector. You would need to do several transforms if you need to move around in different positions. And that kind of leads us to our next topic, which I'll get into in a second. Why would you do this rather than making an assembly and creating a new part in context? So this leads us to the next point, and it's a very good question. And the answer is many won't. And two parts, one part, two parts, I can see users following this workflow. But you can imagine if you had 20 parts that you needed to position, this workflow is not it's going to be very, very tedious, right? It's not something you'll want to do. And that's really when we start getting into in-context assembly design. Now, I think there are users out there who say, one or two parts is okay. I could take that, and I don't need to do the in-context back and forth. But when we start getting into a lot of parts and having to position a lot of parts, that's where in-context assembly design really lends itself. So in the pneumatic cylinder example and the cantilever clamp example, those are real kind of ideal Part Studio scenarios. Bringing parts in is okay as long as it's only a few, but when you start getting into a lot of parts, it just becomes tedious, right? It becomes a lot of effort to position each one. And that's where in-context assembly design becomes really critical, right? So I'm going to get into greater detail on that in just a second, so bear with me. But why did the mate connector appear as derived in the item? Remember, the mate connector was in the Part Studio. When I derive in the Part Studio, I derive in more than just the part. I also derive in the mate connector associated with the part, right? So the derived feature brings in more than just the part. You can bring in sketches or, so there's a lot of things you could do with the derive. But a key thing to keep in mind is it's associated with the mate connector was actually created in the Part Studio in a separate tab. When I drive in that tab, it brings in everything. Mate connector, part, so on. All right, so next thing that I wanted to get into is, as I mentioned, in-context design. And there's really a point where you'll run into limitations with multi-part modeling and large numbers of parts and or moving parts. And that's really when we start getting into in-context design. So again, cantilever clamp, pneumatic cylinder, real simple designs where everything's built from scratch in a single Part Studio really lends itself to that. But when you start getting to more complex motion, more parts to position, especially if you're importing parts from other systems or other software, for example, then in-context design becomes really useful. Now, real quickly, when you go to a drawing, though, you will have all parts, will you not? Forgive me, a question. When you go to a drawing, though, you will have all parts, will you not? Remember, when you create a drawing, you can choose a part within the Part Studio. You don't have to choose the entire Part Studio when you create your drawing. So no, you can select what part within a Part Studio that you want to create a drawing of. All right, so moving on to in-context design. The big difference is, of course, rather than modeling multiple parts in a single Part Studio with no external references, this allows us to build parts with contextual relationships to an assembly, right? And that's a bit different workflow because it's a lot faster to insert a lot of parts into an assembly, right? It's a lot easier to deal with motion, dynamic motion in an assembly. So there are certain designs, certain techniques that are really going to lend itself to in context. If you're positioning a lot of parts, that's a big indicator you should go to in context. If the motion of your design is critical to the design itself, and not just like in the pneumatic cylinder, it has motion, but it's just a simple in and out, right? If your design has, maybe I'm building features around all these positions, and at certain point I need to have a stop at this angle relative to this position of the assembly, that's where in context really comes in, right? When we start talking about, at this position I need this, and this position I need that, and I need to accommodate for this at this certain orientation, that's where it becomes really advantageous. Now, you can do still a lot of this in the part studio, but it's a lot more effort, a lot more transforms, a lot more, work, so to speak, to do the things that are easy in the assembly level. Question: can you move an individual part from a part studio to a separate document? That's a good question. An individual part from within a part studio to a separate document. I don't think so. You can, of course, copy the tab, but that's everything in it. We could discuss workarounds where, you could do delete parts and things like that, but I would ask why. What do you want to do by separating the part from the part studio? Okay, so again, the big thing within context is we're modeling with contextual relationships to the assembly. And, when you're doing those things that make, assemblies advantageous, moving a lot of parts around or dynamic motion, in context just makes more sense, right? So the big thing, anytime you want to relate one part to another in your assembly, sometimes you may have used multi-part, but you didn't realize it. Now you've already built your assembly and this is where you're at. Right? So in context just makes sense in that scenario. The key thing to keep in mind is you can create entirely new parts. It's not just editing existing parts that you've built elsewhere. It's creating entirely new parts that join things together. A good example of that would be linkage. You're designing linkage between parts in your assembly. Linkage is another good example where movement is critical. And, kind of dynamic motion would be really difficult at the part studio level. You're doing a bunch of transforms. So that's where assemblies really lend themselves. So you can create a new part and you can create a feature that's related to different positions of an assembly. So an example would be this folding step stool. I have an open and closed position to a folding step stool, and there are features that really need to tie into that. Right, I need to create a cut in the frame bar to accommodate the open and closed positions so that it stops at both positions. I need to create a cut in the step that perfectly lines up with the frame bar as it's at that, fully opened position. So that's where motion is really critical to my design, and in context assemblies is the obvious choice, right? Now, the other thing I want to mention is you can create multiple contexts, and that's important for a few reasons. I'm going to get into in greater detail in just a second, but just keep in mind you can have several contexts. Maybe your design has several key positions. Your assembly has several important positions that you need to design around. You can have multiple contexts. All right, so let's get into it. What I want to do here is get into a simple example of in context just to explain the basics of it and give you an idea of where you might use it. Now, as I mentioned before, one big example is I just need to position a lot of parts. I showed you the derived with mate connector workflow where we derive in and transform. But as you can see, as you start to get 2 and 3 and 4 and 5 parts, that's not... it's just tedious. It takes a lot of effort, and in an assembly that would be very simple to do, to position. So again, 2 reasons there: motion and then multiple parts to position. But you can see here I have motion is critical in this design. So as this moves up and down, it has these 2 positions that I need to accommodate for. So this would be a good example where I would edit in context, right? So what I want to do, if I look closely, you can see this frame bar needs to have cuts that accommodate for the open and closed position of my assembly. So this is pivoting inside of this frame bar, and I need to make sure that it stops at the appropriate positions. Right? So I'm going to create a cut that matches those open and closed positions. Now, one thing to stress is, although we're creating parts or editing parts in the context of the assembly, all of the part modeling is still done in the part studio. So the way it works is, let's say that I wanted to edit this frame bar. I need to create cuts in this frame bar to accommodate for the various assembly positions. I can right-click the frame bar, and you'll see new options, open and edit in context. Now, this particular assembly already has one context created for that open position. So I can choose open and then edit in context. If I wanted to create a new context, I would choose edit in context. Right? So these are our two context editing options, but if you see, if I right-click from the assembly, I say edit in context, right? That's going to take me back to the part studio for the frame bar. Remember, this frame bar was modeled by itself, except for the rubber feet at the bottom here, but it was just modeled frame bar and the rubber feet, and then the context, all these ghosted parts that you're seeing, are the assembly being brought in. Right? So again, part modeling is still done in the part studio. We're just capturing a snapshot of the assembly, bringing it into the part studio so that you can model around it. Right? And so from here, it's easy for me to say, well, let's create a new sketch, right? And we'll start sketching with relationships to these contextual parts, right? So these parts from the assembly, I can literally just grab an edge of this part. Again, this part doesn't exist in the part studio, it's just in the assembly, but because of the context, I can easily convert it. The moment you create a context, you'll get a little visual cue, or if you're in a context, you'll see a little visual cue, a yellow bar here at the top, indicating this is a context of the assembly, right? But now I've created this first sketch with relationships to the part in the open, or the assembly in the open position, right? So I can hit the green check. We'll bring back our frame bar there. Now I'm going to jump back to the assembly, right? With the go to assembly button there at the top. That's going to take me back to my assembly. Nothing's really changed yet. All I did was convert those entities from the open position. But of course, as I mentioned before, the other important position is closed. And if I rotate this all the way around to close, I need to make sure the cut I make accommodates also for this closed position. So here I'm creating a second context, right? I have an open and closed position. So I can say right click, edit in context. That will create a new context, right? And now I have two. And you can see them in the drop down, right? As soon as I create it. Now, it's important to keep in mind, just saying edit in context doesn't necessarily create a context. It isn't until you actually create a relationship to something in that position that you create a context. So let's go ahead and hide this. And just as I was before, I'm going to, in the same exact sketch, in fact, convert the edges, right? And you can see as soon as I do that, new assembly context, context 1, created. So again, just saying edit in context doesn't create a context. It isn't until you actually reference something from that context that it's created, right? And now I have two contexts, the open and closed positions. And it's easy for me to reflect both. If I wanted to grab the edge here and convert it, I can. And now I have, a sketch that really reflects the range of motion that this assembly is going to have, right? The open and closed positions that it's going to have, right? So now I can go from here, extrude, remove, right? We'll do symmetric, maybe 1/4 inch, right? Green check, and I can mirror that to the other side if I need to, just using the normal feature mirrors, right? So all the normal commands that you're used to. I think I'll mirror about the right. Yep, there we go. And so now I've created a cut. I've mirrored the cut to the other side, and that cut reflects both the open and closed position. So two different contexts within this assembly, right? All right, so one big tip that I have when you're doing this, if you're creating more than one context, make sure to rename them something useful. And the reason I say that is, it's easy when you have one maybe even 2 to remember what they are. But when you start having 3 and 4 different important positions, context 1, context 2, context 3 aren't really helpful names, especially when you're coming back 6 months later to remember, how this thing was constructed. So just remember, renaming your context in the Part Studio can really help to, give a little bit of intent, right? To illustrate what's going on, even to someone else that may open this up. So you can rename your context, by the way, from the dropdown. Now, the inevitable question is, when you're doing this, well, how do I make sure that things change, they update? Questions. If I edit in context to create a base sketch and then model multiple features based on that sketch, then later change the assembly and update the context, will all subsequent features update based on the contextually updated sketch? Yes, and that's a good technique. One thing I want to stress, it kind of gives you this ability to do what we often refer to as layout sketches, where a sketch kind of drives not just the position of parts, but maybe even the length and size of parts. So in this example, the sketch here is actually what drives the length of the frame bar and a few other pieces. So you can, in the example, create a base sketch and then model multiple features with relationships to that base sketch, and then change the base sketch and have your assembly update. Of course, you would need, updating the context, right, clicking and doing so. But yes, absolutely, it will allow you to do that kind of that layout sketch workflow. I think a lot of users are familiar with. The long leg should be 2 instances of the same part. No, this is one bent bar. Both of these are just one bent bar. So this is one part, 2 parts. Yeah, that is not the case. Moving on. Can a contact be created? Can a context be created from an imported part? Yes. I'm assuming you mean context. If you can create a context with imported geometry, there's no issues with that. Mirror of slots should not have been required. Forgive me, I'm not sure what you're referring to there. All right, so as I mentioned before, this is one bent frame bar, and this is one bent piece here. These are not 2 independent legs. All right, so let's move on. Now, this is creating a context, again, with relationship to 2 different positions. One question, I actually want to take a moment to answer a question that was posed on the forums. And there's actually 2 questions. The first is, how to and when do we use move to new subassembly and create new subassembly? And if you'll bear with me for a moment here, I want to jump into an assembly and kind of give you a brief demo of these 2 tools. So in the assembly, you can create subassemblies on the fly, right? And if you right-click a part or parts, you will see 2 options that tie into this: move to new subassembly and create new subassembly. Now, create new subassembly, like the name implies, will create a new subassembly, but the key thing is it's blank, right? So you will create a new subassembly. It will add it automatically to the instance list, but nothing will be in it, right? So in order for you to insert parts into your subassembly, you would expand out the subassembly in the instance list and drag parts into that subassembly, right? So just keep in mind, you can reorder your parts, expand them out, insert them into subassemblies if you choose to from this dropdown, right? Now, also with this is the ability, let's delete, to control select several parts. Let's say maybe I wanted to make a subassembly on the fly of 10 different parts in my top level today. I want to move to new subassembly, right? The main difference there is it will create a new subassembly and then move your parts into that subassembly, right? So it doesn't create just a blank subassembly. It actually takes parts and moves it into them. Now, if you insert 2 or 3 or more parts and they have mates between them, those mates will also carry over. In this example, everything's grouped, so you don't see that, but just keep in mind the mates between parts will also carry over into the subassembly when you do this move to subassembly. So move to new subassembly moves the parts you've selected into the new subassembly. Create new subassembly just creates a blank subassembly that you would then need to insert your parts into. If I set up a various chronological context based on each other after being updated, would I have to update those contexts in order? Yes, you be careful about. That's a good question. When you create context, you would want to update them. If you've created several contexts that depend on certain positions, the order will become important, especially in certain scenarios. So I would say, in general, when you're updating context, you want to update them in an order that makes sense, and also be very conscientious of the hide show state of parts and the orientation of parts when you're updating context. Okay. How do I move an instance to another existing assembly in the hierarchy, not create a new? You should be able to drag from the instance list. Drag the part from one assembly to another one in the instance list. Can you add folders in the parts studio? You can add folders in the document, but no folders in the parts studio. If you're asking, can I add folders like to the feature list? The answer is no. Okay, so can you add folders to the parts studio? I assume you mean feature list in the parts studio, and the answer is no. You can add folders in the document level for managing all your tabs across the bottom, but that's a different thing. So, all right, so just real quickly, I want to wrap things up here by jumping back to my slide. So again, driving home the question of when would I use multi-part versus in context. There are really two questions that I would ask myself when I'm getting started to decide whether I would use one or the other. A, is motion critical to design? And what I mean by that is not just simple in-out motion like a pneumatic cylinder, but do I need to model around various positions in my assembly? And if the answer to that is yes, then in context is your choice. The second question I would ask myself is, do I have to position a lot of parts from other sources, either parts I've modeled before or parts I've imported? Do I need to position a lot of parts in order to build my various other relationships? If the answer to that is yes, then you would use in context. But if the answer to both these questions are no, then multi-part modeling is your answer. So I think for most users, this will make it as simple as possible. Motion critical, or do you have a lot of parts that you need to position to model around? Then the choice is kind of determined by them. So I'm going to stick around and answer any questions. I see there are a few questions left, so I'm going to stick around and answer them. Bear with me. So I want to say thank you everyone for joining, and we'll have a good day.